Hello everyone, my name is Ngangum Sweetie Chanu, pursuing MTech first year second semester. Today I'm going to give a presentation on the topic high pressure processing of foods under the guidance of Dr. Charulata Mahanta, Professor, Department of Food Engineering and Technology. Here are the contents starting from introduction, principle of HPP, that is the high pressure processing, mechanisms of HPP, HPP operation technology, types of HPP, high pressure processing, effect of high-speed treatment of foods on microorganisms, packaging requirements for HPP treatment, factors influencing the microbial sensitivity to HPP treatment, which is followed by applications of HPP on food preservation, effects of HPP, high pressure, on the food quality, which is followed by the combined effect of high-speed treatments with other non-thermal processing methods, and the advantages and disadvantages of high-speed treatment, which is followed by the conclusions, and finally the reference. Now, let's come to introduction. Nowadays, the consumers increasingly demand convenience foods of the highest quality in terms of natural flavor and taste, and which are free from additives and preservatives. This demand has triggered the needs for the development of a number of non-thermal approaches to food processing. Among these approaches of non-thermal processing of food, this high-pressure technology has proven to be very valuable. So now let's see what is meant by this high-pressure processing of food and its role in food processing industry. High-pressure processing, it is the method of preserving and sterilizing food in which the product is processed under very high pressure, leading to the inactivation of certain microorganisms and enzymes present in the food. The applications of this pressure, that is the high pressures, to the food rather than heat enables the destruction of microorganisms without causing significant changes to color, flavor, and nutritional attributes of the food product. This high-pressure processing unit was first designed and constructed by Bert Hite in 1899 for the purpose of pasteurization of milk. Here in figure 1 shows the schematic representations of high-pressure processing of packed foods. In this case, the foods are usually vacuum packed and placed in a basket, which is then loaded into HPP machines. The two openings are closed with end closures, and a pressure transmitting liquid, which is usually water, is used to pressurize the vessel. Then, the foods are held at a particular pressure for a specified duration, followed by quick decompression and unloading of the product. The principles of high-pressure processing needs to be known for better understanding of the processing techniques. There are two general scientific principles which are of direct relevance to the use of high pressure in the food processing. They are Le Chatelier's principle and the isostatics rule. In this Le Chatelier's principles, it states that when a system at equilibrium is disturbed, the system's response in such a way that tends to minimize the disturbances. This means that the high pressure stimulates the reactions that result in a decrease in the volumes but dampens the reactions that involve in the increase in the volume. Any phenomenon, examples phase transitions, change in molecular configurations or chemicals reactions that is accompanied by decrease in volumes will be enhanced by pressure. The second one is isostatic rule. The isostatic rule states that the pressure is instantaneously and uniformly transmitted throughout the sample under pressures if the sample is direct contact with the pressure medium or hermetically sealed in a flexible package that transmits pressure, which means that the pressure is transmitted in a uniform, that is isostatic and quasi-instantaneous manner throughout the sample, and the time necessary for pressure processing is therefore independent of sample size in contrast to thermal processing of food. Next is the mechanisms of high pressure processing and its components. A typical high pressure processing system consists of a high pressure vessel and its closures, a pressure generation system, a temperature controller, and a material handling system. In these high pressure vessels, the cylindrical vessel is constructed by a low alloy steel of high tensile strength, and the wall thickness is determined by the maximum working pressures and the vessel diameters and the number of cycles for which the vessel is designed. And in case of these closures, most fast cycling CIP systems use interrupted threaded closures, allowing very fast opening and the closings of the vessels, and hence the minimum vessels downtime for unloading and the loading of the product. In most current applications of this high pressure processing of foods, the pressure medium is simply water mixed with a small amount of soluble oil for lubrications and anti-corrosion purposes. After all, air is removed from the high pressure vessels. The high pressure is generated by direct compression, that is piston type, or indirect compression type, that is the pump type. In direct piston type compressions, the pressure medium in the high pressure vessels is directly pressurized by piston. This method allows very fast compression but is in practice restricted to a small diameter laboratory or pilot high pressure system. The indirect compressions method, in this case, a high pressure intensifier is used to pump the pressure vessels until the desired pressure is achieved. For this method, only static high pressure seals are needed within the high pressure vessel. So these are the mechanisms and the components of the high pressure processing. This is the complete flowchart of high pressure processing operation technology. First, the food is packed in a sterilized container or flexible package, and they are loaded in a pressure chamber, followed by the filling of this chamber with water. After this, the chambers is pressurized and hold under pressures for a specified required period of time. After this, the chamber is depressurized again, and after the depressurization of the chambers, the final product, that is the after processing, they are loaded and removed from the pressure vessel. Here in figure 2, it shows the flow diagram of the complete operations of high pressure processing unit. As mentioned in the flow chart here in this picture, the unprocessed food, they are loaded in the chambers, and then which is followed by the filling of the chambers with the pressure transmitting medium, that is the water in this case, and pressurize the chambers and hold under pressure for a certain period of time. And after this depressurization takes place, and after this depressurization, the processed food is loaded from the pressure chamber. Types of high pressure processing. The high pressure processing treatment which is done in the food industries has two major types. They are batch type and semi-continuous types. In batch types, the food is prepared and aseptically sealed in plastic containers, then placed in a pressure chamber for pressurizing using pure water as the transmitting fluid. In this system, pressurization is done either by pumping medium into the vessels or by reducing the volume of the pressure chamber by using a piston. After this, the chamber is then decompressed and then the product is loaded. We know that most high pressure machines industrials use for food processing are batch systems which can be used for both solid and liquid foods. Next is semi-continuous systems of high pressure processing. In these systems, it is recommended if the product is pumpable, and these systems consist of a pressure vessels with a free floating pistons to compress the liquid foods. The free floating pistons is mainly used to divide the vessels into two chambers, thus separating the product from the pressure medium. Then in this case, pressurizations of the fluid in the second chamber leads to the compression of the products in the first chamber. After an appropriate holding time, the pressures on the pressure transmitting fluid is then released. Then, the treated liquid is discharged from the pressure vessel into a sterile Hall tank through a discharge port. Unlike in batch systems, the semi-continuous systems require an additional system such as aseptic filling stations to package the products after the treatment. So these are the two types of high pressure processing. Here in figure 3 shows the schematic diagram of high pressure processing equipments. One is horizontal and the other is vertical type. Next comes with the effect of high pressure treatment of food on microorganisms. High pressure can be utilized either as a cold pasteurization process or as in combinations with the thermal energy for pasteurization. High pressures can damage the cell membranes of the microorganisms, denature enzymes, and cause the changes in cell morphology. The increase of pressures in the cell environment disrupts the membrane permeability, followed by the loss of membrane integrity and swellings, which leads to cell death. A pressures of 100 megapascals can induce partial protein denaturations, and 200 megapascals can cause damage to the cell membranes and internal cell structures. Apart from this, increasing the pressures to 300 megapascal or more induces the irreversible denaturations of enzymes and proteins. The two important factors influencing the effectiveness of the high-pressure processing treatments against the microorganisms are the chemical compositions of the food products and the types of microorganisms. So these are the brief effects of high-pressure treatments of the food on microorganisms. Therefore, the effects that high pressures have on microorganisms can be categorized primarily as a change to the cell morphology and inhibitions of metabolic reactions essential for cell maintenance and genetic mechanisms of the microorganisms. Next is the packaging requirements for high pressure processing treatment. As mentioned above, the food products need to be packed in a flexible container prior to high pressure processing in a batch system to compensate for potential volume reductions in the food products inside the package during the processing treatment as well as the collapse of the headspace. So when selecting the packaging materials, several factors should be taken into account. They are the safety of the food materials, the possible formations of the compounds that influence the odor and the taste of the food, and the effects of pressures on the mechanical and physical properties of the packaging material. It should be packed in such a way as to accommodate a 10 to 20% decrease in volume reductions during the pressurization process. So, considering that the packaging materials should be flexible enough to transmit pressures and withstand the volume change, the materials such as glass, metals, and papers are excluded in this type of packaging requirements. For high pressure processing, the polymeric materials such as polyethylene terephthalate, polyethylene, polypropylene, ethylene vinyl alcohol copolymer and their combinations are usually used as the packaging materials. Here in figure 4 shows the packed products of some of the high pressure treated food products. Now let's see what are the factors that are influencing the microbial sensitivity to high pressure processing treatments of food products. Various intrinsic and extrinsic factors can affect the pressure resistance of the microorganisms such as species, strain, stage of growth, and the food composition. A good understanding of the influences of these factors is essential for optimizing the high pressure treatment and ensuring microbiological safety. First is the pH of the food products. The pH of food is one of the main factors affecting the growth and survival of microorganisms. All the microorganisms have a pH range in which they can grow and an optimum pH at which they can grow best. At acidic pH values, the extent of pressures-induced inactivations will generally be enhanced so that the recovery of subletally injured cells are inhibited in this pH range. For example, the pressure resistance of E. coli in orange juice is dependent on the pH of the juice, the degree of inactivations increasing as the pH decreases. The second factor is the water activity of the system. By water activity, we know that it is the amount of water available for microbial growth. So by lowering the water activity of a food products can significantly influence the growth of a food spoilage or food poisoning organisms. So by reducing water activity appears to protect the microbes against inactivations by high pressures in most cases. And it is supposed that a low water activity can lead to the stabilization of protein, thus preventing the protein denaturations and decreasing the efficacy of high pressure processing treatment. The third factor is the temperature. By increasing the temperature, will generally increase the numbers of microorganisms inactivated. So, the temperature required for complete inactivations of microorganisms can be reduced by the combinations of high pressure treatment and a moderate heating. The introductions of thermal energy during the pressurizations can make high pressure treatment more effective at low pressure. The next factor is the high pressure related parameters. The high pressure related parameters include the magnitudes of pressures, pressure holding time, compressions and decompression rates. The degree of eliminations of microorganisms increases with increasing pressures and pressure holding time. A low compression rate increases the total process time and affects the product throughput. And the last factors that influence the microbial sensitivity to high pressure processing treatments is the compositions of the food. The food compositions plays an important role in determining the susceptibility of microorganisms to high pressure. The food ingredients such as proteins, fats, sugar, salts, and minerals increases the microbial resistance to pressure. Therefore, the influence of food compositions on microbial susceptibility to pressure should be considered when selecting the high pressure related parameters for microbial inactivation. Now, let's come to the application parts of high pressure processing on food preservation. The high pressure processing treatments finds its applications in many food preservations in many ways. Some areas of food processing sectors where this high pressure processing has more potential includes fruits and vegetables processing, dairy products, and then animal products. The first one is the applications of high pressure processing on fresh fruits and vegetables. In fruits and vegetables, this high pressure processing helps in extensions of shelf life of the product. It inactivates the microorganisms and quality deteriorating enzymes. It also maintains the higher organoleptic, sensory, and nutritional properties while improving the safety of the food products. Some examples of fruits and vegetables products that can be processed by high pressure processing treatments are juice, purees, jams, smoothies, slices, chunks, ready-to-eat products, etc. So in this figure 5, it shows the fresh fruits products which is treated by the high pressure processing treatment. The second one is the applications of high pressure processing on dairy products. The applications of high pressures on milks was first initiated with a view to develop an alternative process for the pasteurization. It helps in the elimination of spoilage and pathogenic microorganisms that are present in the milk, and it also helps in the extension of shelf life. This high pressure processing can improve the coagulation properties of milk and can increase the cheese yield, thereby indicating its potential applications in the cheese making technology. In figure 6, it shows one of the high pressure treated milk products. The third one is applications of high pressure processing in animal products. The high pressure processing in meat products maintains high sensorial and nutritional qualities. It also improves the product safety without the need of additives or artificial preservatives. The high pressure processing influences the tenderization, sensation process, color of the food products, and the extent of lipid oxidations. This high pressure processing also helps in the extension of shelf life by inactivating the microorganisms present in the meat product. Some examples of meat products which are produced by this high pressure processing includes sliced ham, turkey or chicken cuts, sausage, whole pieces of cured ham, etc. In figure 7, it shows high pressure treated meat products. Now let's see what are the effects of these high pressures on food quality. While food safety and shelf life are often closely related to microbial quality, other phenomena such as biochemical reactions, enzymatic reactions, and structural changes can significantly influence the consumer's perceptions of food quality. This high pressure treatment at moderate pressure generally results in minimal changes in the odor, flavor, or other sensory characteristics of food products. This high pressure treatment at certain conditions can alter the physiochemical, sensory, and functional properties of food ingredients, particularly protein, lipids, and the stars. So the influence of high pressure on the four aspects of food quality includes the food color, texture, sensory quality, and the food yields. So now let's see what are the effects of these high pressures on the individual's food qualities. First is the effect of these high pressures on food color. Color plays an important role in consumers' acceptance towards the food products. For fruits and vegetables-based products containing the natural pigments like anthocyanins, carotenoids, chlorophylls, moderate high-pressure treatment has a limited effect on their color characteristics. In this case, the stability of pigments can be affected by high pressures at a certain high temperatures and nor a high pressure. For example, raising the temperatures to 50 degrees Celsius during pressurization resulted in the degradation of chlorophyll in broccoli juice. The next one is the effect of high pressures on food texture. The knowledge of rheological or textural properties of food products is essential for product development, quality control, sensory evaluations and designs, and evaluations of process equipment. The physical structures of most high moisture products remains unchanged after exposure to high pressures, since in this case there is no shear forces are generated by the pressures. But for gas-containing products treated under high pressure, the color and textures may be changed due to gas displacement and liquid infiltrations. In such cases, the physical shrinkage can occur due to mechanical collapse of air pockets, and shape distortion may be related to the anisotropic behavior. But for foods containing no air voids, high pressure usually results in minimal or no permanent change in textural characteristics. The third one is the effect of high pressures on food sensory quality. We know that the sensory analysis is the most straightforward way to evaluate the quality and consumer acceptance of food products. The sensory qualities of foods can still be affected by high pressure to a certain extent, although this high pressure has proven a promising preservation technology. So, the alterations in the sensory characteristics of high pressure treated foods are associated with the physical and chemical changes induced by this high pressure. The last one is the effect of high pressure on food yield. High pressure treatment may affect the yield of certain products, a very important economic issue for food manufacturers. The food yield of a product depends on the type of product and intensity of the treatment. The high pressure treatment can give a higher yield in food products than the thermal treatment and treatment without pressurization. Here in table 1 gives the summary of the quality characteristics of several high pressure treated food products. From the previous slides, we know what is meant by high pressure processing its process mechanisms, and its roles in processing so many food products in many food industries. So now let us have a look about the combined effect of this high pressure treatment with other non-thermal processing methods. Many attempts have been made by researchers to study the combined effect of high pressure treatment with other non-thermal methods to explore the possibilities of synergy between the processes. The first one is the combined effect of this high pressure treatment with gamma radiation. The combined effect of high pressure and gamma radiations for inactivating Clostridium sporogen spores in chicken breast was studied in 1996 by Crawford et al. In their study, it was known that the applications of high pressure, that is a 600 megapascal, for 20 minutes at 80 degrees Celsius reduced the radiation dose required for 1 log reduction of Clostridium sporogens from 4.2 kg to 2 kg. The second one is the effect of high pressure treatment with the combinations of alternating current. The exposure of microbial cells and spores to an alternating current, that is the 50 Hz, resulted in the release of intracellular materials causing loss or denaturations of cellular components. In this study, it was found that the high pressure treatments at 300 megapascal for 10 minutes for Escherichia coli cells and 400 megapascal for 30 minutes for Bacillus subtilis spores after the alternating current treatment resulted in the reductions of the survival fractions of both the organisms. The third one is the combined effect of high pressure treatment with ultrasound treatment. In this case, the pre-treatment with ultrasonic wave, that is 100 watt per centimeter square for 25 minutes at 25 degrees Celsius, followed by high pressures, that is 400 megapascal for 25 minutes at 15 degrees Celsius, was shown to result in complete inactivations of Rhodotura rubra. The fact is that neither this ultrasonic nor high pressure treatment alone was found to be effective. So the combined effect of these two treatments results in the complete inactivations of the species. Advantages and disadvantages of high pressure treatment. Various advantages and disadvantages can be derived from this high pressure processing of food. Now let's see first what are the advantages of this high pressure processing of food. This process is environmental friendly since it requires only electric energy and there are no waste products. It can be applied at room temperatures, thus reducing the amount of thermal energy needed for food products during the conventional processing. This high pressure is independent of time or mass, that is, it acts instantaneously, thus reducing the processing time. Also, this high pressure is not dependent of size and shape of food. Since high pressure processing is isostatic, that is uniform throughout the food is preserved evenly throughout without any particle escaping the treatment. Apart from the advantages which can be derived from this high pressure processing treatment, there is still some disadvantages of these treatments in a certain point of view. Now let's see what are the disadvantages of this high pressure processing treatment. Most of the pressure processed foods need low temperature storage and distributions to retain their sensory and nutritional qualities. During the process, some food enzymes and the bacterial spores are very resistant to pressures and require very high pressures for their inactivation. Also, the residual enzyme activity and dissolved oxygens results in enzymatic and oxidative degradations of certain food components. In addition to this high pressure processing has high capital costs for the processing equipments. So these are some of the disadvantages which can be derived from the high pressure processing treatment. Now let's go to conclusion. Consumer demand for fresh, safe, and nutritional food products has led to the emergence of novel food processing technologies such as high pressure processing treatment. This high-pressure processing treatment is a consumer-acceptable, environmental-friendly, scientifically recognized method to achieve the higher quality in certain foods. This has several advantages over conventional heat treatment process in terms of ensuring food safety and quality as well as extending the shelf life of the food product. This high pressure can inactivate endangered microorganisms and enzymes in foods at the relatively low temperatures while the organoleptic and nutritional properties of foods are less affected. So, the destructions of microorganisms and inactivations of enzymes at low or moderate temperatures shows that the high pressure technology has the potential to be used in the development of new generations of value added products. These are the list of references which I refer for my presentation. Now, I will wind up here. Thank you everyone for listening.